All right, welcome to this explainer. Today, we're rolling up our sleeves and diving straight under the hood of ServiceNow's hardware asset management. We're going to trace, troubleshoot, and actually fix the asset refresh process. Look, if you manage hardware lifecycles, you already know that keeping those refresh pipelines running smoothly is absolutely critical, not just for your budget, but for your end users too. Okay, let's dive right into this. I mean, we've all seen it happen, right? You're looking at a record for a device that is practically older than dirt, a laptop that literally belongs in a museum, but for some reason it's still not triggering your automated refresh workflow. It's incredibly frustrating, and it forces us to ask, where exactly is the system logic breaking down? To solve this little mystery, we're going to map out the exact flow. Here is our agenda. We'll cover the synchronization challenge, debugging the evaluation engine, model variables and calculations, troubleshooting the refresh flag, forecasting eligibility pipelines, and finally, safe testing and deployment. Let's kick things off with part one, the synchronization challenge. So before an automated refresh can even be considered by the system, you really have to realize that ServiceNow requires strict data alignment between two historically distinct domains. On one hand, you've got the financial asset repository. This governs things like purchasing costs, depreciation, and contracts. On the other hand, you've got the technical operational configuration item, or CI record, which maintains service mapping and technical connections. It's kind of like two different sides of the brain trying to communicate. And the crucial point here is that without automated synchronization between those two domains, you are guaranteed to end up with a huge mess of conflicting data states. You might have physical devices marked as perfectly operational in your CMDB, but they are entirely out of sync with your financial depreciation schedules. This kind of data mismatch completely breaks the proactive replacement processes we're trying to troubleshoot today. And honestly, it can even complicate your future out-of-the-box platform upgrades. Moving on to part two. Debugging the evaluation engine. Now, the eligible for refresh flag on your hardware records isn't magic. It's a highly specific, calculated output. It gets triggered by a four-step chronological flow that executes every single week on the platform. First, a scheduled job runs. Second, that job calls a script include. Third, it queries the overarching hardware model category, so think Windows laptops versus Unix servers, to find its specific values. And finally, it outputs that true or false flag. Here's the kicker. If your models aren't categorized correctly, the script just can't populate the data, and this entire flow stops dead in its tracks. So if you're a platform administrator, consider this your treasure map. If your refresh pipeline is broken, open up your instance right now. These are the exact system names and backend sys IDs you need to look at. You can manually execute that SAM-calculate asset refresh eligibility scheduled job in a subprod environment and check the system logs against the script include. Doing this lets you step right through the code and see exactly which model categories are failing to populate the required data.
All right, part three, model variables and calculations.
So what exactly is that script include looking for when it evaluates your hardware? Well, it primarily relies on the useful life field. This is basically a benchmark measured in months. But importantly, this field lives on the overarching hardware product model record, not the individual physical asset itself. This means your asset's eligibility for refresh is entirely dictated by how you've set up the useful life for that specific model category. And this beautifully illustrates the core mathematical formula driving the whole refresh engine. It's brilliantly simple, really. The projected end of useful life date simply equals the asset install date plus the model useful life in months. That's it. So if your scheduled refresh job isn't flagging assets correctly, your very first debugging step is to check this equation. Are your installation dates populated? Does the parent model actually have a useful life defined? Because if even one variable is missing, the whole engine fails. Which brings us to part four, troubleshooting the refresh flag. Picture this scenario. You've noticed an aged laptop, you order the replacement through the hardware asset refresh order catalog item, and you've successfully deployed the shiny new hardware. Awesome, right? But then you look at the system and the old asset remains stubbornly flagged as eligible for refresh. No way. So what gives? Well, the root cause here is usually a misunderstanding of how the engine actually works. Fulfilling the tasks within a refresh order doesn't just magically erase the flag on the original asset. Remember, the scheduled job only evaluates the asset's age relative to the model's useful life. To fix this perpetual flagging, you've got to physically transition the old asset out of active service. This means following your standard protocols to actually retire the original asset record. Or if you're dealing with a delayed massive fleet upgrade, you can manually adjust the scheduled retirement dates in bulk to temporarily pause the engine's flags. Let's look at part 5, forecasting eligibility pipelines. You see, relying solely on that weekly scheduled job we just debugged is actually pretty insufficient for high-level financial planning. Why? Because the job only tells you what has already expired. It's totally reactionary. IT procurement and financial analysts need dynamic pipeline forecasting. They need the ability to project the exact future dates for impending hardware expirations so they can proactively structure future budgets. By taking that core useful life equation we discussed earlier and building database reports around it, your financial teams can group impending expirations into specific fiscal periods. This creates a really powerful rolling forecast for your capital expenditure budgets. You aren't just reacting to broken laptops anymore, you're predicting exactly when, say, 500 devices will age out in Q3. It's a real game changer. Finally, part 6, safe testing and deployment. I have to issue a massive warning here. Never, ever copy your live production hardware asset data directly into your sub-production development environments. Production asset databases are absolute gold mines of highly sensitive information. Doing a full copy exposes things like software license keys, financial contract details, and deep network configurations. It is a huge corporate compliance and security risk. Just don't do it. Instead, follow this responsible deployment framework. First, extract a small scrubbed data subset. Usually about 10 to 15% of your production data is plenty for testing. Second, keep your configuration elements strictly isolated in update sets, totally away from transactional data. And third, before you flip the switch on any automated state transitions, run parallel read-only queries in production to validate your scripts against live data volumes. Ultimately, the system's logic for hardware refresh is incredibly straightforward, but it's completely 100% reliant on the quality of your underlying data. So if your hardware refresh process is stalled, I'm going to leave you with this final diagnostic question to investigate in your own instance. Are your database variables, specifically your install dates and your model category useful life metrics, actually clean enough to trust the automated engine? Take a look at your instance this week, run those queries, and find out. Thanks for joining me on this explainer.